Okay, I want to show in this tutorial very quickly how you can use Voronoi. Nothing really fancy, just very quickly. And you might sometimes for your subdivision prefer to use Voronoi. So I'm here going to use populate 2D as basically populate 2D basically randomly generates series of points in the 2D space. And if you type Voronoi, you can see that first it wants the points for the Voronoi diagram. You can just add that and it already generate that. It's kind of nice, but at the same time, I don't recommend using Voronoi because it already has been used so many times. Definitely don't recommend it. But sometimes you can produce good stuff with it. So let's say this is a rectangle that our Voronoi is gonna be, and then you can also use the same rectangle. So actually, let's assign it a rectangle to that rectangle. Let's say it's this, and you can use this for both the region here as well as the boundaries here. So this defines that where the Voronoi is going to be finished. Optical cell radius, this would give you that, and then the planes. But more than that, in itself is not interesting. You might be able to apply it in certain ways. So let's just start experimenting with it here a little. So you have all the points as a center point. You can obviously change the radius of each. You can think about, and I'm again very quickly want to show you this, you can think about attractor points that can affect the radius of this. So you can use poo points. We know how to use this attractor points. We have used it many times in the past. So you can divide these distances to a smaller number. So, and then use minimum to cap the numbers to a smaller range. So let's see what we get. And then, oh, actually, before I do that, let me make sure, because we know the factor should be smaller than 1. And we'll see what we get. And if you want to make sure that that is something that you are seeing, you can use bound to make sure that that's a good one. So it's very small near here, and over there is big. And you can use loft, obviously, we talked about these things, or you can move these, all these inner curves in a way upwards. And you can also move them according to the distance to these points. So you can copy these parts again. So have another attractor points that affect the movement of these, so you can graph them. So basically it treats each of these cells as a separate cells. So they're putting in a different pockets. So now we can move them each individually. Let's not move the loft for now. I don't need it really. So basically we move each of these points individually according to a new attractor points that we are going to define. So let's say this is our point, or in fact, why not you just use the same point? So let's not define a new point actually. And so from our old points, we see what are the sort of distances, and then we calculate all the distances. The only thing is that we don't need to have such a small number, so we can actually have a really bigger number and move and use that number as sort of way to move all these items we have. One thing I want to check is that how many items we are seeing here. We're seeing 100 locally defined values, meaning that there's 100 cells here. How many items we are seeing here? 100. So it should be good. Let's try. Not happy about it. Oh, we have to graph this too, because and obviously it's not happy because you can't just add the value to move. You have to use amplitude. In fact, Sorry about that. So let's say you have Z factor that it's according to our attractor points there, and you can cap it, so like that. And now this is our new cells, and we can loft our new cells to our base old cell, which was already produced with the Voronoi here. Remember that we have to graft it, otherwise we won't be able. So you can either graft it this way or just right click. Basically, I just want to show you that these two are exactly identical. Either you graft it or you just right click here and just put graft. It doesn't really matter. And I want to just internalize this attractor point. And now if I change this, you can see that it's responding to our attractor point. You can think about ways that each of these cells move toward an attractor point, so they're not just moving in one direction. So this would be your challenge. Think about how you would add a vector. So imagine you have a point in the space, like somewhere here, and then you want to use these points for these cells to move toward that attractor points. So that would be your task. And let's see how you can do that. And also think about variation in the length of those, and obviously you can give this thickness, and that would be one way to think about it. Yeah, that's pretty much it.